Hey guys, welcome to InterviewBlog. In this video, we'll be covering one of the most important coding interview question, which is the two-number sum. So the question gives us an array of integers and an integer value which represents the target sum. The question wants us to determine two numbers from the given input array such that if we add those two numbers, it will give us the target sum. The question tells us two things. The first thing is the given input array consists of distinct integer elements. That is, no integer element is repeated in this array. And the second thing that the question says is there is always only one pair of numbers such that if we add those pair of numbers, it will give us the target sum. So let us see this example. In this example, we can see that all the integers, that is 9, -1, 2, -12, 10, -7, and 11 are occurring only once in the array. So this given array consists of only distinct elements. And the second thing is the question says that there is always going to be only one pair of elements which gives the target sum. So in this example, we can see that the elements 11 and -1 when added with each other gives the target sum, which is 10. There cannot be another pair in this given input array such that if we add those pair of elements, it will give us the target sum. So there is always going to be only one pair, and the pair in this given input array is -1, 11. So we are asked to return that pair as our answer. So hope you got the question. Let us now see how to solve this problem. Actually, there are three different approaches that are used to solve this problem. So we are going to see it one by one. The first approach is the naive approach, which is the normal brute force solution. The second is the time optimized approach, and the third is the space optimized approach. Naive solution is not that much important, so we are not going to cover it deeply, but the time and space optimized solutions are really important for coding interviews. So we will be covering these two approaches deeply. Before moving into the time and space optimized approach, let us quickly cover the naive solution first. In simple terms, in this approach, we will be generating all the pairs of numbers one by one, and we will be checking if any of that pair is equal to the target sum. If we find any pair that is equal to the target sum, then that pair is returned as our answer. So to generate the pair, we will be using two for loops. The first for loop, that is the outer for loop, is going to traverse the array elements one by one. Let's say the iterator for the outer for loop is I, and the inner for loop is going to traverse the elements from I plus 1th index to the end of the array. With these two for loops, we'll be generating the pairs of numbers, and at each step, we will be adding those two pairs of numbers, and we'll be checking if that added value is equal to the target sum. And if it is equal, we'll be returning that pair as our answer. So in this example, first, our outer for loop will be visiting this element 9, and our inner for loop will visit all these elements, that is -1, 2, -12, 10, -7, and 11. So what will happen is, first 9 will be added with -1, and it will give us 8. We will be checking if 8 is equal to the target sum. Since it is not equal, we will again add this 9 to 2, and we'll be check if 11 is equal to the target sum, and no, since it is not equal, we'll be adding 9 plus -12, which gives us -3, and -3 is not equal to target sum. Hence, we will again add 9 plus 10, which gives us 19. 19 is not equal to the target sum, which is 10. So we'll again add 9 plus -7, which gives us 2, which is not equal to the target sum. And next we will add 9 to 11, which gives us 20, which is not equal to the target sum. So now our outer for loop will visit this element -1, and our inner for loop will visit all these elements one by one. So now we will check if -1 plus 2, which is 1, is equal to the target sum. Since it is not equal, now we will check -1 with -12. That is, we will be adding -1 plus -12, and it will give us -13. We will check if -13 is equal to the target sum, and it is not equal. So we will be adding -1 plus 10, which gives us 9, and we will check if this is equal to the target sum. Since 9 is not equal to 10, we will again add -1 with -7, which gives us -8, which is again not equal to the target sum. Hence, we will add -1 with 11, which gives us 10. And now this 10 is equal to the target sum. Hence, we have found the pair that is -1, 11. If the elements from this pair is added, we get the target sum. Hence, we'll be returning this pair as our answer. So hope you got the solution. Let us now analyze the complexity of the naive solution. So the time complexity of our naive solution tends to be big O of n square, where n is the number of elements in the given input array. So our time complexity is big O of n square. This is because we are using 2 for loops, and the space complexity of our solution tends to be constant since we are not using any extra space. So next, let us see the time optimized approach. So in this approach, we are going to solve the problem by traversing the array just once. And for this, we will be using an extra helper data structure, which is also known as an auxiliary data structure. And in this case, we are going to use a hash table. So hash tables are nothing but key value pairs. So they are just like dictionaries in Python. So using this hash table, let us see how to solve this problem. Previously in the brute force solution, we just found pairs of numbers. That is, we generated pairs of numbers where each pair contains 2 numbers A and B, and we will be checking if A plus B gives us the target sum. So this mathematical formula can also be written as B is equal to target sum minus A. So we are going to use this formula. This is because while traversing the array, we will be visiting each and every element. And in each and every step, we will have 2 values. That is the value of that element, which is A, and the target sum, which is given to us as 10. That is, we will be knowing A and target sum. With this, we will calculate B. How will we calculate B? Using this formula. That is, B is equal to target sum minus A. So after calculating B, we will check if this B is present in the hash table. If this B is present in the hash table, it means that we have found the pair. That is, we have found A and B. Both of these elements are present in the given input array, and hence we can return this as our answer. And if B is not present in the hash table, we will simply add that A to our hash table, saying that we have visited the number A. That is, we have the number A in our array. So do not worry if you are confused. Let us now simply dry run and see how it works. Let us now see this example. So as I said earlier, I'll be using a hash table to solve this problem. So first, I'll be visiting the element 9. So this element will be our A. So to find B, I'll be subtracting this 9, that is A, from the target sum, which is 10. So our B is 1. So now I'll be checking if this B is present in our hash table. Since B is not present in our hash table, I will simply add 9 to the hash table. So I'll be adding 9 as my key value and true as my value. So next, I'll be visiting the element -1. So -1 is my A now. So I'll be subtracting -1 from the target sum, which is going to give me 11. So now we have found that B is 11. Now I'll check if this B is present in the hash table. Since B is not present in the hash table, that is 11 is not present in the hash table, I will simply add -1 to the hash table, saying that it is present in the array. So next, I'll be visiting the element 2. So now my A is 2, and I will be subtracting 2 from 10. That is my target sum to find B. And now my B is 8. Now I will check if my B is present in the hash table. Since 8 is not present in the hash table, I will be adding 2 to my hash table, saying that it is present in the array. Next, I'll be visiting the element -12. So now my A is -12, and if I subtract negative 12 from the target sum, which is 10, I will be getting 22. Now I will check if this B value, that is 22, is present in my hash table. Since 22 is not present in my hash table, I will simply add the value of A, which is negative 12, to the hash table, saying that it is present in the given input array. Next, I'll be visiting the element 10. So now my value of A is 10. So while subtracting 10 with 10, I'll be getting my B value as 0. So now I'll be checking if this B is present in my hash table. Since 0 is not present in the hash table, I will add the value of A, that is 10, to my hash table, saying that it is present in the input array. So next, I'll be visiting the element negative 7, and now my value of A will be negative 7, and I'll be subtracting negative 7 from the target value, which is 10. So we'll be getting 17 as our value for B. Now I'll check if this B is present in the hash table. Since B is not present in the hash table, I'll be adding the value of A, which is negative 7, to the hash table, stating that it is present in the input array. So next, I'll be visiting the element 11, and now my value of A will be 11, and I'll be subtracting 11 from the target sum, which is 10, and while subtracting, I'll be getting my B value as negative 1. Now I will check if this B value is present in my hash table. We can see that our B value is present in the hash table, that is negative 1 is present in the hash table, which means that we have already seen negative 1 in our given input array. So we have found the pair of numbers, that is A comma B, that is we have found the elements 11 and negative 1, which when added gives the target sum. Once our B value is found in the hash table, our function will be returning A comma B as our output, that is we will be returning 11 comma minus 1 as our output. Please note that the order of the elements returned doesn't matter. We can either return negative 1 comma 11 or 11 comma negative 1. It is up to us. So hope you understood the time optimized solution. Let us now analyze the complexity of our solution. So the time complexity of this solution tends to be big O of n, where n is the number of elements present in the given input array. So our time complexity is linear because we are just traversing the given input array once to find the solution. The space complexity of this solution tends to be big O of n. This is because we are using a auxiliary data structure, which is a helper data structure, and we are almost storing n-1 elements in this hash table. So our space complexity also tends to be big O of n. So hope you understood this solution. Next, let us now see the space optimized solution. In this approach, the first step is to sort the given input array. So after sorting, I will be getting negative 12, comma, negative 7, comma, negative 1, comma, 9, comma, 10, comma, 11, comma, 13. So after sorting the array, I will be using two pointers, that is ith pointer and jth pointer, to traverse the sorted array. So initially my ith pointer is going to point to the first element of the given input array, I mean that is the sorted array, and my jth pointer is going to point to the last element of the sorted array. So next, at each and every step, I will be calculating the current sum. So the current sum is nothing but the sum of the elements pointed by the I and jth pointers. So if my current sum is less than target sum, in this case, I will be incrementing my ith pointer. If my current sum is greater than the target sum, in this case, I will be decrementing my jth pointer. If my current sum is equal to target sum, in this case, we have found the pair of numbers, that is the elements that are pointed by the I and jth pointer is our answer. So I will be returning that as the output. Let us now see this example. So initially my ith pointer is pointing to the first element of the sorted array and my jth pointer is pointing to the last element of the sorted array. So I will be calculating the current sum as the sum of elements pointed by my ith pointer, which is minus 12, and the element that is pointed by the jth pointer, which is 13. So this is my current sum. So my current sum is now 1. And now while comparing my current sum with the target sum, which is 10, my current sum is less than target sum. So I'll be incrementing my ith pointer. So I'll simply move my ith pointer from negative 12 to negative 7. So next I'll be calculating the current sum, which is the sum of elements pointed by my ith pointer, which is my negative 7, and my jth pointer, which is 13. So my current sum is 6, which is less than the target sum, which is 10. So since my current sum is less than the target sum, I'll be incrementing my ith pointer once again. So I'll be moving my ith pointer from my negative 7 to negative 1. So next I'll be calculating the current sum, that is I'll be adding negative 1 and 13. In this case, my current sum is 12, which is greater than my target sum, which is 10. So in this case, I'll be decrementing my jth pointer. So I'll simply move my jth pointer from 13 to 11. So next I'll be calculating the current sum by adding the elements negative 1, which is pointed by my ith pointer, and 11, which is pointed by my jth pointer. So I'll be getting 10. Now we can see that the current sum, which is 10, is equal to the target sum, which is also 10. So in this case, we have found the target sum, that is we have found the elements which when added gives the target sum, and hence those elements are nothing but the elements pointed by my I and jth pointer. So I'll be returning negative 1, 11 as my answer. So hope you got the solution. Let us now discuss the complexity of this solution. The time complexity of our solution tends to be big O of n log n. This is because we are sorting the given input array in our first step. So sorting takes n log n time, and hence our time complexity tends to be big O of n log n. If the interviewer says that the given input array is already in sorted fashion, then in that case, we are simply using two pointers I and j to visit all the elements of the given input array. Hence, in that case, our time complexity will be big O of n. The space complexity of our solution tends to be constant. This is because we are simply using two pointers I and a to traverse the entire array, and we are not using any extra helper data structure. So hope you understood all the approaches. Let us now implement it in code. All right. So we got our two-number sum function defined, which takes in an array and a target sum. So first, let us see the brute force approach. So in this approach, I'm simply going to traverse the array. That is, my I is going to traverse the entire array. So I'll be saying for I in range, len of array, and my inner loop is going to traverse from I plus 1 to the end of array. So my first number is going to be array of I, and my second number is going to be my array of j. So I'll be checking if my target sum is equal to first num plus second num. In this case, I'll be returning the elements pointed by the I and jth pointers, that is my first num, second num. So this solution has a time complexity of big O of n square and a space complexity of big O of 1. So hope you understood the brute force approach. Let us now test our brute force approach. So my array contains elements 9, -1, 13, -12, 10, -7, and 11. So our target sum is 10. So let us call our function saying two number sum of array and target sum. So let us now run our solution. So yes, we are getting -1 and 11 as our answer. Next, let us now implement the time optimized approach of our two number sum. So I'm just going to comment out all of these. So in this approach, as we discussed, I'm going to use a hash table as an auxiliary data structure. So now I'll be traversing the array for I in range len of array. So while traversing the array, I'll be having two known values. That is, my A value is going to be the element that is present in the ith index, and we know the target sum value. So with this, I'll be calculating my B value as target sum minus A. So after calculating the value of B, I'll be checking if B is present in my hash table. So I'll be saying if B in hash table. In that case, if B is in hash table, it means that we have found both the numbers which when added gives the target sum. So I'll be returning A comma B as my output. If B is not present in the hash table, we'll simply add A to the hash table. So I'll be saying hash table of A is equal to true. So hope you understood this solution. So this solution has a time complexity of big O of n and a space complexity of big O of n. This is because we are using a hash table, so our space complexity needs to be big O of n. So let us now test our solution. So I'll simply copy this and remove the comments. Let us now test our solution. So yes, our function has returned 11, -1. So the order doesn't matter. The only thing that matters is these two elements, when added up, they should give the target sum. So in this case, 11 - 1 gives the target sum 10. So hope you understood the solution. Let us now test our solution. So I'll simply copy the solution. So this is Leetcode problem number 1, which is 2 sum. This is the same problem that we discussed so far, but the only difference is here we have to return the index instead of the elements. That is, here we have to return the index of the elements which when added gives the target sum. So I'm simply going to paste our solution here and I'll just change our solution to return the indexes. So in the hash table, instead of storing the Boolean value true, I'll be storing the index of the element A. And while returning, I'll be returning the indexes. So I'll be saying I comma hash table of B. So this hash table of B is going to be the index of B. That is, when B is found in the hash table, it will give me the index of B and I is the current index. So I'll be saying return two number sum of nums comma target. So let us now test our solution. So our solution got accepted. Let us now run all the test cases and check our solution. So yes, our solution got accepted. Let us now implement the third approach, which is the space optimized approach. So I'm simply going to comment out these So as we discussed in the explanation part, we're going to use two pointers, I and j, where I is going to point to the first element of the array and j is going to point to the last element of the array. So I'll be saying while I is less than j, we'll be calculating the current sum as the sum of the elements pointed by the I and jth pointers. So array of I plus array of j. So if my current sum is less than target sum, in this case, I'll simply be incrementing my ith pointer. Else if my current sum is greater than target sum, in this case, I'll simply be decrementing my jth pointer. Else, that is, if my current sum is equal to the target sum, I will be returning the elements pointed by the I and jth pointers. If the interviewer says that the given input array is already in sorted fashion, then we don't have to sort the given input array. Otherwise, our first step is to sort the given input array. So in this case, I'll be saying array.sort to sort the given input array in place. So hope you understood the solution. So this solution has a time complexity of big O of n log n and a space complexity of big O of 1, which is constant. So let us now test our solution. So I'll simply copy this down. I will uncomment it and let us now test our solution. So yes, we are returning -1, 11, which is the right answer. So let us now copy our solution and check if it works for all the test cases. All right, this is Leetcode problem number 167, which is 2 sum 2. This is the same problem that we discussed so far. The only difference is that here the given input array is in sorted fashion. So we don't have to sort it. So I'm just going to paste our solution here and I'll be removing this array.sort since the given input array is already sorted. And please note that here we have to return the index of the elements, which when added gives the target sum. So as we did in our implementation, we are not going to return the elements. We are simply going to return the indexes I, j. But here in the question, it is given that given a one indexed array of integers. So generally an array is 0 indexed, but here they are given a one indexed array of integers. So we have to simply return I plus 1, j plus 1. So here I'll be saying return 2 number sum of numbers, target. So let us now test our solution. So our solution passed the sample test cases. Let us now submit our solution and check whether it passes all the test cases. So yes, our solution got accepted. Please note that for this solution, we are not sorting the given input array and hence our time complexity tends to be big O of n, where n is the number of elements in the given input array, and our space complexity tends to be big O of 1. Since we do not use any extra space, we just use 2 pointers I and j to solve our problem. So hope you understood the problem and all the approaches. Do subscribe and check out our channel for more videos. Thank you so much.